Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco's DevNet organization, and I'm back to talk to you about NX API Part 2, diving into the Nexus object model. This is a part of our Network Programmability Basics video course, and we are in the Network Device APIs module. Now this lesson is a follow-up to NX API Part 1, where we got started with the native APIs and NXOS. In this session, we're going to go even deeper and look at the object model that underlines NX API REST. Now, if you want to follow along with me, please do. I encourage you to go up on GitHub, github.com/cisco-devnet/netprog_basics. And you'll find information for every lab in the whole video course. Each lab includes a README that shows you how to set up your own laptop and environment to follow along with all the exercises. And for labs like this one that require a bit of infrastructure, DevNet Sandbox is standing by, and all the specifics on how to reserve those sandboxes are located in the READMEs. Now in this lesson, we're going to pick up where we left off, and we're going to look at OpenNXOS model-driven programmability. We'll look at the key components of how this all comes together under the hood with the data management engine, the DME, and the management information tree, which is what we're interacting with NX API REST. We'll look at Visori, an included tool in NXOS to interfacing and working through the object model. And then we'll look at how we can use Postman to make our NX API REST calls. Now to start out, OpenNXOS model-driven programmability. Though we use models under the hood, if you want to access it through programmability, we do need to turn on the feature. So we start off with enabling NX API feature. Now if you've already enabled this to take advantage of NX API CLI, then you don't need to re-enable it. It's the exact same feature that's there. And as we covered in the first part, or part 1 of NX API REST comes along with NX API CLI, but rather than using the CLI options, we're using an object model. That's right, we're leaving the CLI behind and we're saying hello to objects. NX API REST is a true REST API that targets resources, also known as objects, and each object has methods and properties that give access to the details across the NXOS system. NX API REST is much more powerful than NX API CLI, but it does come with a bit of a steeper learning curve, and we'll get you started up that curve in this lesson today. Now the data management engine and the management information tree is what we're interfacing with, what we're working with when we leverage NX API REST. Now the DME is there and running on your device no matter whether you're using NX API REST or not, because it provides access to the management information tree, the data, the details about your device, no matter what platform or interface is being used. So NX API REST will consume information from the data management engine, but so does CLI, JSON RPC, and all of the other agents that are out there. The data management engine, the DME, then interfaces with the NXOS processes that are actually running the software on your switch for routing, switching, and other services that are there. So we've talked about the management information tree. The DME provides access to the management information tree. But what is the MIT, or the management information tree? Well, it's the assembly of all of the objects that NXOS is made up of. Everything in NXOS is an object, be it an interface, a statistic, a VLAN, doesn't matter. They're all objects, and every object has a class that will identify its type. Now, every object has a parent-child relationship. One object will, or any single object will have a single parent. And as we assemble the children and the parents, we create that MIT, that management information tree. Now, the whole tree builds from root, known as SYS, SYS, inside of NXOS. Now, as we go through and we talk about the objects, objects will have two names that we'll refer to them as. We start out with the relative name. Now, the relative name is how we identify an object related to all of its siblings, and it will be unique within a parent object. If we use an example like a family, the Smith family, for example, Tom and Jill are relative names for the children to Mr. Smith. Now, the distinguished name is how we actually get the unique identification across the management information tree, and it's created by combining all of the relative names together. So back to our example, while Tom is a relative name, Tom Smith is his full distinguished name. Jill Smith is her distinguished name as we go through. Now, when we're just working within a particular context, we can simply use the relative names, those short names, if we're just talking amongst all of the objects underneath a particular parent. But when we're working in a larger context across an entire system, we'll want to leverage the distinguished names for our objects. So let's leave the Smiths behind for a moment and talk specifically about some of the NXOS objects. So here I have a table of a small subset of objects and object types available in NXOS, with example RNs and DNs as we go through. Now everything starts at the top level, sys. That's the parent of the whole system. And then as we go down, we get individual object classes and types. So we start out with an interface list is the object we're interested in, the list of interfaces on the device. The RN, the relative name for the interface list, is INTF. We create the entire DN by combining that with its parent, which is sys. So sys/INTF is the distinguished name for the interface list. And if we query sysint, we get the entire interface list from the system. If we want a particular interface, say a physical interface, the RN, the relative name for a particular physical interface, is PHYS, phys dash, and then in square brackets, the identifier for the particular interface we're interested in. In this case, ETH1/1. ETH1/1, 1/2, they'd all be constructed, their RNs, in that same type of system. Now, when we want to refer to a particular physical interface across the entire system, we need its distinguished name. And so we combine its relative name with all of its parents. And that gives us sys/INTF/phys dash, and in square brackets, ETH1/1. If we move from physical interfaces to VLANs, our VLAN list, its RN is BD. Now BD stands for bridge domain. The object model that backs up NXOS is built upon the object model that started out with ACI. And in ACI, bridge domain is the layer 2 concept that goes through. So when the object model was mapped back into NXOS, we kept the bridge domain name for its closest cousin, or it's what's relative to the bridge domain inside of NXOS, and that would be a VLAN, which is why the VLAN list is referred to as BD. So to get the full VLAN list using NX-API REST in the management information tree, the distinguished name is sys/BD. Every individual VLAN is identified with BD dash, and then in square brackets, the VLAN number that's there. So we get the distinguished name with sys/BD, BD VLAN1. We continue like this through all of the different types and objects that are there, be they IPv4 information with VRFs and interfaces and addresses, or all of the other data. Now the full object model reference is available up on DevNet, so you can find all of the details for all of the objects there as you go through and explore NX-API REST. Speaking of exploring, let's take a look at Vizori, a capability that's included with NXOS. Now, similar to the sandbox, which is enabled for interfacing and working with the NX-API CLI when you turn on NX-API, Vizori is enabled automatically with NX-API as well. It is a web page hosted on the box, and that we get to it by navigating to the IP address /vizori.html. And Vizori gives us the ability to navigate through the entire object model, as well as expose the NX-API REST calls necessary for working with and replicating what you're seeing in Vizori. If we look at the Vizori interface itself, it starts out up at the top, where we can identify either a particular class or distinguished name that we're interested in. We can filter that down based on properties of an object. So we can identify a property name and then values so that we can further scope down what type of objects we're looking for. We'll see the results of our query displayed here, and we'll see if for a list object or a list query, we would see the objects repeated, all of the matching objects repeated in the list. When we look at an individual object, we see some elements inside it. First, we've got the ability to actually navigate from the parent to the children using the green greater than and less than arrows embedded inside of the output. But we also have indications so that we can look at statistics, faults, and health of a particular object that's there. If you're looking for the specific DN or just to look at the specific object that you're looking at, we have a link inside of Vizori to view that single object as well. And then finally, up at the top, you can actually view the NX-API REST details. So you can see the full URI that you would use to make a request to retrieve this specific information that Visori is showing you. Now, if we want to make a class-based search, so remember, a class is a particular type of object, and every object has a class that goes through. So there's a class for interfaces, a class for VLANs, a class for VRFs, and we can use NX API REST and Visori to search for all instances of a particular type. In this example, we're seeing how we can use Visori and NX API REST to search for all VLANs, and here we've actually filtered it down for all VLANs other than VLAN 1. We're not interested in that default VLAN. And so we do a class search. The class we're interested in is L2BD. Now we want to set a property. ID is not equal to 1 so that we do not return back VLAN 1. And then we can actually look at the specific URI to view that full REST API that goes through. We can see how that filter is attached to the API call itself. Now as we make that search, we'll get the entire results list that comes back. And because this was a class search, we'll see multiple instances of L2BD in our scrollable web browser. Each instance represents a different VLAN. We can see here a web VLAN, an app VLAN, and a data VLAN to keep with the normal web app data types of constructs that we talk about. Now, rather than search by an entire class, we can search by distinguished name to look for a specific object and/or all of the children for that object. Now, here we can see an example of how we might look for interface Ethernet 1/1. So to do that, we need to search for its distinguished name. We can't search for a relative name. We do need the full distinguished name. So in this case, it would be sys, INTF, fizz, Ethernet 1/1. We can see the REST API call that is laid out here on how we would search for that specific interface. As we look at the results for that, we'll see all of the details scrollable in the web browser for all of the properties available for this particular object that we searched for. Now that we've seen some of the examples of how to use Visori here in the browser, or in the PowerPoint, let's take a look at a quick demo on how we can actually walk through Visori to look at some different information that's out there. All right, so for this demo, we're going to take a look at how the Visori interface works along with what we've talked about inside of the presentation so far. So I'm starting out with just Visori itself. So we've navigated to the IP address of the Nexus device /visori.html. We can see that in our web browser here. And it'll default to showing us the top of the management information tree, which is just the top sys. So we can see that here we can see the DN is sys because that is the top of the tree. Now, as we talked about in the slides, we've got these nice arrows that let us actually drill deeper in. So if I wanted to see the children of sys, I can just go through, and this will then let me walk into the management information tree one layer at a time. And we'll see that there are 81 children of sys at the top level, starting with information about users out there with the AAA user EP pieces that go through. Now let's look at some of the examples of things we might be interested in, and we'll go to that default for network engineers and network as we go through, and we'll look at VLANs. And if you remember back to the presentation, those are called BDs or bridge domains, and the class name is L2BD. So I can search for L2BD using Visori here and run the query. Now you'll notice the browser comes up and says, I didn't specify a property. Are you sure you want to find all instances? And in this case, yes, I do indeed. So once I make that search, I can see that there are 4 objects shown. Our first one here is VLAN 1. Well, if I scroll down in the list of the page here, we'll see that I've got other VLANs listed. So here's my web VLAN, which is VLAN 101, and I've got VLAN 102, gives me my app VLAN as it goes through. Now coming through and getting all of my VLANs is handy, but maybe I'm looking for a particular VLAN. But I don't know the distinguished name for that VLAN specifically. I can actually use the class query to hone in on it. So let's say I'm looking for layer 2 BD. I'm still looking for that class, but I want to go ahead and I'm looking for a particular VLAN ID. So I can say ID equals, and we'll say VLAN 102. So I'm looking specifically for a layer 2 BD with an ID of 102, and I can run that query. Now by running that query, now I see I got a single device or a single object back. It's a layer 2 BD. It is indeed my app VLAN, and I can see all the information that's there for this particular object. In addition to the distinguished name. If I were to click on this, it would take me and do another query specifically for this distinguished name as a MO query. Now other things that are useful in here is I can look at the children of a particular VLAN. Yes, actually VLANs do have children. If I come through here, I can see protocol information. I can see statistic information about this VLAN. Now, this VLAN's not doing much right now because it's just a VLAN with nothing connected in my demo, but we can see all of the interesting information about the VLAN we're looking at. I'm going to go back a page to look specifically at this VLAN here as well. Now next we're going to move into looking at how we can use Postman to make API queries, and what's important there is understanding the URI for a particular query. And that's where this display URI of last query is helpful. We can see this is the actual NX API REST query for what we just requested. Now we'll diagnose and we'll dive into the components of this in just a minute, but some of the interesting bits here we can see down here at the end where we've got a target filter in and we're showing ones that are equal to the ID of 102. Inside of Vizori is a great tool for working and exploring the object model to become more familiar with it so you can write more powerful programmatic scripts in your network automation use cases. All right, now with the demo completed, let's dive back in and look at how we can move from Vizori into Postman. All right, now that the demo's over of Vizori, we're going to move ahead and we'll take a look at how we can actually use NX API REST with Postman to make those API calls. As a reminder, Postman is that simple but powerful REST API client where you can quickly test APIs using a nice graphical user interface. You can save those APIs into collections, manage multiple environments to make it easy to replicate these API calls across different infrastructure platforms. Lets you auto-generate code, very useful tool for working with REST APIs. Now, REST APIs are all about the URI, so here's a cheat sheet on how to construct a URI for an NX API REST call. Now, it'll start out with HTTP or HTTPS in the address, and then we'll do API. If you remember back to NX API CLI, we still went to HTTP, the device address, /INS. Here we're changing to /API to make NX API REST calls. Following that, we have a query type. Now, as we saw when we worked with Vizori, we can query based on class, layer 2 BD, or we can search for a specific object or an MO, where we target a specific instance of an object by its distinguished name. After the query type, we move into identifier, either the class name or the specific distinguished name that we're searching for. We identify the format, whether we're interested in XML or JSON data to come back, using a URI here. Now, this is used instead of HTTP headers, which is a more common mechanism for indicating the type of data format that you're interested in. And then following the format, we can provide optional query parameters to impact return results. Some examples of the query parameters might be query target. What is the scope that we want? Are we just looking for a particular object, or do we want to see all the children of an object? Or do we want to see both the object and the object's children as part of the full subtree that's there? Very useful option to go through with your query. And then you can also filter down. You can only return results that are that match a particular. You can only return objects inside of a class query that match a particular parameter or a property that you've searched for. And we saw some examples of that with Vizori. Now, with this in mind, let's look at how we set up our environment for NX API instead of Postman. No surprise, we need to provide the host, username, and password. In this case, for a particular NXOS device we're going to go for. This is the same host we used in the NX API CLI examples. With that in place, we can make our first request, which has to be a login request. NX API REST uses a different mechanism, though it's very similar to how we saw with NX API CLI. We'll make a post. Our initial request will be a post to /API/AAA or AAA login.json. The body of that post will be the information including our username and password. Now, when we make that request, the NXOS device will send back a response that includes a token information. Now, that token information is there, it's there for our reference, but it's actually sent back and forth using session cookies, very similar to how NXOS worked. With that login request done, we can move ahead to making actual NX API requests for classes or distinguished names. And first, we'll take a look here how we can recreate that class query using Postman. So we start out with a GET request. We're retrieving information. Remember, NX API REST is a REST API, which means it uses the verbs inside of HTTP just like any other REST request. So in this case, we're trying to retrieve information, so it's a GET request. And we'll take the actual URI straight out of Vizori. There's no need to recreate it. so we'll copy and paste from Visori into the Postman interface. Once we have that in place, we can send that off and review our response details. And we can see in this case, we pulled directly out of Visori, so it comes back in XML. If we wanted to change that and explore how we could return JSON data, we would change the URI from .xml to .json. And in our original request, we looked for all VLANs that were not equal NE to VLAN 1. If we were to change that to EQ, now we would retrieve back just VLAN 1 itself. Feel free to explore with Postman how to adjust this query to see different VLAN numbers as well. Now, outside of the class query, the next one you might want to do is a specific object, back to our interface Ethernet 1/1. Here we make our request. It's once again a GET request, but our URL is slightly different. Rather than a class query, now we're doing a query for an MO, or a specific managed object. And we provide the distinguished name for Ethernet 1/1, and we can review the response details. Now, once we have a particular managed object, we can actually use NX-API REST to update it. And so we switch from a GET request to a PUT request to update the interface description for our object. So it's the same URI, but now from GET, we go to POST, and we provide a body with the updates we're interested in. In this case, we're simply updating the description and providing configured with NX-API REST. We send this off, and we can review the status code, which comes back as a 200 OK, and we'll notice we get no data back. You would verify that this was successful by sending, once again, a GET request for this object and viewing the results. Now, we've seen GET and PUT. There are other HTTP methods supported by NX-API REST, as you would expect. GET, POST, PUT, and DELETE are all supported as you would expect from a REST API type of a method to either return, create new objects, update details about objects, or delete an object. So in summary, what did we take a look at in this one? Well, we started out by exploring the difference between model-driven programmability and CLI-based options. We looked at the management information tree and how it provides the basis for all of the model-driven programmability around NXOS. We used Visori to explore the object model and look at the NX-API REST URIs, and then converted those into Postman calls that we can make using that tool. Now, we're not done yet. Make sure you complete the full Network Programmability Basics course to dive from device level. Next, we go into controllers and how we can use controllers across entire network systems. If you didn't run the exercises along with me, you still have time. Make sure to download all those exercises from GitHub and run them on your own. Join DevNet for more information and learning labs and development sandboxes and code examples. Now, if you do have further questions, feel free to come find me. You can reach me on email or Cisco Spark at hapresto@cisco.com. I'm available on Twitter at hfpreston and on GitHub at hpreston. And be sure to follow DevNet as well on all the social medias at Cisco DevNet. Thanks once again for joining me for this lesson. I look forward to our next one where we'll dive into network controllers. Thanks.